Hey everyone, in today's video I'm going to be making a compound called Hexaaminenickel II Chloride, perhaps the longest named chemical I've ever made. And it's actually very simple to make. It's a complex between nickel chloride and ammonia. So all we need here is what I have as a solution of nickel chloride, concentrated solution of it, nice emerald green, and we're going to combine that with concentrated ammonia solution that I've also made, and acetone, which I distilled in my previous over-the-counter purification video.
Okay, I've transferred 2 milliliters of the solution into a test tube, and now I'm going to add the concentrated ammonia. So as you can see, there's a nice emerald green color, and when we add the ammonia, we should see a series of pretty beautiful color changes. So I'll add this 1 milliliter at a time. Oh, and by the way, all of these reagents, the acetone, the ammonia, and the nickel chloride were all chilled in my lab fridge before this, just to bring them down to a cool temperature. That's because this step right now produces quite a bit of heat. So we'll add the ammonia. Just 1 milliliter of it. You can see we get a really cool layering effect, and I'll just swirl that around to mix everything. It's a bit darker green, so I'll add another milliliter. And you can see we're starting to get this really beautiful color change from that deep emerald to a really deep royal blue. Let's do a third milliliter. And why not? We'll do a fourth as well. Now you can really see the very deep blue coloration. This is from the ammonia complexing with the nickel chloride. So nickel chloride in solution has actually got 6 water molecules attached to it. So what we're doing in this reaction is we're displacing the water molecules with ammonia molecules. So it goes from nickel chloride hexahydrate to the reagent that I wanted, which is the Hexaaminenickel II Chloride. And that's really apparent in the equation, which I'll put in the description. So now we've got this really beautiful blue color of the hexaamine complex in solution. And now what we want to do is take it out of solution. So that's where the acetone comes in. We're going to add the acetone, and what that's going to do is reduce the polar nature of the solution. So acetone is much less polar than water is. So once we add that, it should push the complex out of solution, and we'll get yet another nice color change. So here we go. You see, as the acetone is added, we get a precipitate. And just by feeling this, yeah, it's a little warm. It's a good thing I cooled it down. So we'll swirl this around to mix everything. And we get a beautifully colored precipitate, which looks to be white, but that's just because the rest of the solution is such a dark blue. So if we keep adding acetone, what's going to happen is it's going to push all of this complex out of solution, and we should end up with a nearly colorless solution and a nice lavender precipitate. Now you can start to see the purpley color of it. So I'll keep adding a good amount of acetone, quite a bit more than the solution I started with, to again push everything out of solution. This is another reason, by the way, that I chilled everything beforehand, to further reduce the solubility of this compound and get as much as possible out of solution. So now you can really see the purple color. So I'll keep on adding acetone and then give it a minute to let it settle. So we're most of the way through the addition now, and you can see there's quite a difference between the color of the solution from when it started. It's a much paler blue, and the precipitate is very definitely a lavender color. It's very compact too. You see it settles quite quickly, which is nice. So now you can see when I add more acetone, it should drive more of this precipitate out of solution. See, now there's almost 3 distinct layers. So we'll give it a stir.
So after adding a whole bunch of acetone, I had to move to a larger test tube, and I wanted to show you how cool this is to watch it settle, because like I said, it's such a heavy precipitate. So this is just after mixing it again, and now if I leave it alone for a minute, it'll settle out, and it's really beautiful to watch. And this is in real time, by the way. Here's another view that's sped up 4 times and under different lighting conditions.
So here's my product. After putting it back in the fridge for a couple of hours and letting it settle a bit, you can see nearly all of the color is gone from the solution, and we're left with a pretty nice heavy purple precipitate at the bottom. I think the remaining cloudiness in the solution is just from really tiny particles of the hexaaminenickel II chloride that are just suspended, and that would take a good while for that to settle out, but I don't think I'm going to wait for that. So what's on the left, I had to graduate to a larger test tube because I had to use a whole lot of acetone to get everything fully precipitated. So the one on the left was what's been from the rest of the video, and the one on the right was just 1 milliliter of solution that I used as a test earlier. Interestingly, I also tested ethanol as a precipitant, and this is the result of that. You can see it didn't do anything at all. I had heard that ethanol could also be used in place of acetone because it's also less polar than water. But probably what happened with mine is I was using Everclear, the 75.5% ethanol version of Everclear, and I guess that's just got too much water in it, so it could never reduce the polarity enough to get the precipitate. So anyways, you can see that it stayed that nice blue color. And this is kind of a nice comparison between what the blue used to be, what the solution used to look like, as to what it is now after the addition of acetone. So now the last thing I'm going to do is just take this and filter it off and collect the solid product. And I'm going to filter this outside, I think, just because the majority of this is acetone, so it's going to smell pretty awful. And when I'm filtering it, I'll be washing it with a few more amounts of acetone just to rinse off any of the liquid. I don't want to wash it with water, of course, because then it would redissolve in the solution, and that's not what I want. So here's my final product of solid hexaaminenickel II chloride. I ended up with about 0.6 grams of it from the total of 3 milliliters of the nickel chloride solution that I used. So I've got quite a bit of solution left, but it's going to take me a while to process the rest of it. I'll probably end up having to distill some more acetone to finish it, just because I had to use so much for this one. So once I finish off the rest of this, I'll let you know how much I got and what my yield was. But you can see it's just this really beautiful lavender color. And I've sealed it in a glass ampule for storage, because what I noticed was I left some out to dry, and it looks like it's at least mildly air sensitive. So you can see that the residue on the filter paper here is completely discolored. It's all green now. So compare that to the purple that it was. So I guess on exposure to air, or maybe even something just in my lab here, it reacted with it and discolored it. So I'm going to store it in this ampule just to make sure that it's protected from the air. So you may be wondering why I wanted to do this synthesis. What's the purpose of hexaamine-nickel-II chloride? What's the use of it? There really was no purpose, to be honest. It just sounded like a really cool synthesis that I wanted to try. There's really not a lot of purple compounds out there, and especially not of nickel. Generally, nearly all nickel salts are some kind of shade of green, so it's pretty rare to find a purple one like this. And it's a fairly simple synthesis that I could do easily and come out with a neat product. So, hope you enjoyed. I had a lot of fun doing this one. Thanks for watching.